Welcome, everyone. I think we'll get started here. This is an OpenTEAM in-depth series webinar or learning session. And today we have with us Rikin, Gandhi, and Vineet Singh from Digital Green, who are going to share about FarmStack, which they newly launched, which is a protocol to enable the secure exchange of data by managing farmer consent, enforcing data protection rules, and codifying community governance roles. So we're excited to hear more about them. And for those who are new to OpenTEAM, we're the Open Technology Ecosystem for Agricultural Management, a project of Wolf's Neck Center for Agriculture and the Environment. And we operate in a pre-competitive space where we bring community members, organizations together to learn from one another and build the knowledge base of the community in a way that can foster coherence and collaboration that can serve our diverse membership. So we don't seek only to find solutions and recommend them, but also to explore during this learning series. So thanks again for joining, and I will turn it over to Rikin and Vineet, who I believe have a bit of a demo, and then we can go into some Q&A.
Perfect. Thank you so much, Laura, and great to connect with all of you. It's great to be part of the OpenTEAM community. So I'll start with a couple of just intro slides about how we landed on this work, FarmStack. As Laura mentioned, it's essentially meant to be an open source protocol to enable the secure transfer of data across the ag ecosystem. And it came about through our work, primarily working on ag extension services, primarily in the global south in countries like India and Ethiopia, where we partner with government extension services that are involved in training farmers on ways to increase their productivity in a sustainable way through various types of farmer field school and demonstration plot types of training programs, and where we train these extension programs to produce videos that are by farmers and for farmers to share these sustainable agricultural practices more efficiently. Done that with more than 2 million odd farmers, the majority of whom are women, with about 45,000 odd government extension workers at the village level across these countries where we operate. Now, as we've done this work, a ton of data has been collected by these government extension agents and the farmers that we work with as well about the practices that they're getting exposed to, the practices that they actually adopt and apply on their farms, and how that changes from season to season. And we have this pretty rich data set that comprises all these 2.3 million farmers' data. And largely has been used to inform the production and distribution of new extension information, including the production of new videos. But what we've sought to see with FarmStack is to say that, well, it shouldn't be Digital Green or even our government extension providers who should be the sole arbitrators of these farmers' data. There's a real opportunity to flip the paradigm so that farmers have greater control over their own data, so that they can take, for instance, the data that these extension services have about them, for instance, what types of practices that these farmers are adopting on their fields, and be able to share it with, for instance, a bank for a credit scoring purpose, or with an off-taker who might want it for traceability or for ecosystem service market purposes. And in a lot of the markets that we're working in, there's been a real explosion of agri-tech action. India has more than 1,000 agri-tech startups who've gotten more than $1 billion worth of investment in just the last 3 years. And what that's doing is bringing in a lot of new talent and financing into the space, which is really exciting. But on the other hand, also fragmenting the ecosystem with respect to data. And there are also regulations that are existing and are being developed in places like India and Kenya that are, for instance, like GDPR. There's an India data protection bill that is expected, for instance, to pass through Parliament this year. And there's a need for these agri-tech startups, the government, the civil society organizations that also work with farmers to ensure that they are building from the get-go in a way that builds trust and that ultimately gives greater control to farmers themselves over these systems. And so where we ended up focusing with FarmStack is to say that, we don't want to be in the space where we think that there is a lot of need for action when it comes to apps and platforms, that there is a lot of actors and there's ever more. And much of that ends up being in the competitive space. But how can we support that space of both public and private action by building sort of enabling protocols that can protect the interests of the farmers in the first place, but also enable the wider ecosystem of platforms and app and other service providers too. And so that's where we've landed on really focusing on the need of protocols as a digital public good, in much the same way that we have on the internet for protocols that enable that ecosystem. And so with FarmStack, the main focus area is with respect to being a protocol is to say that this is totally open source, so that anyone can dig into the code to establish its security and trustability, and that it codifies some of the community governance rules that organizations have with one another, whether that's like fiduciary responsibilities on how data liability is managed. And then for data providers to be able to codify the rules that they might want to set on data consumers. Because a lot of country governments that we work with, including like Ministry of Agriculture in India, Ministry of Agriculture in Kenya, are trying to build various types of big data platforms for agriculture. But much of what they're doing is like very centralized and oftentimes limits the interest of data providers to want to participate in these marketplaces, because in the absence of having a usage policy that protects a data provider's interests, a data consumer can just pull a data provider's data and be able to, for instance, just store it to file or publish it onto the web, and essentially it defeats the whole purpose of the marketplace. And so with this whole notion of usage policies, there's restrictions that essentially a data provider can enforce in code on a data consumer. And then this whole notion of peer-to-peer data connectors, so that instead of an aggregate centralized data store, instead enable organizations and individuals to share data directly with one another, not through digital green or any other third party, but just directly between data providers and consumers. And for farmers to be able to have mechanisms to manage their consent in a way that they can also, for instance, revoke access over time if for providers that they don't want their data to be shared with, and to address this issue of fragmentation that these farmers are also witnessing, for them to have an ability to discover what types of services or applications they might want to share their data with. And so usage policies basically go beyond just the typical access control that we're all familiar with of just binary, I give you access to my data or not. And if I give you access to my data, you can essentially store, forward, do whatever you want with my data, and go a little bit further with respect to a higher order abstraction of creating obligations around what you can do with my data, restrictions like how you can process my data or what types of microservices you can use my data with. So that's what we mean when we talk about data usage control. And that if you bring it together, that like a data provider, including a farmer, who consents to say that my data can be used for this or that particular service, that data is shared, again, directly peer-to-peer to a data consumer, but is restricted in how that data consumer can process that data or store that data or forward that data with this usage policy around it. How this is affected is through this notion of a trusted execution container, which Vineet will describe more in detail when we kind of jump into the demo. But just one final slide to say that where we see this going is essentially building out a network of sorts of all these participant nodes, whether they be organizations or farmers themselves, being able to codify their data usage policies amongst one another, have those enforced, and that for there to be a steward, which could be an entity in the work that we're doing in India and Ethiopia, we see the ministries of agriculture taking on that steward role to begin with, but we envision that steward role, just like you have on the World Wide Web, being eventually managed by a consortium of public and private actors who essentially have the role of certifying which are the actors who can be part of this network, what are those usage policy templates that they can use in their network that conform, for instance, to jurisdictional data protection laws around encryption or privacy and the like. So that's kind of the larger ambition. But where we are right now is that we've just released the open source protocol on GitHub and have built a friendly user interface for organizations and individuals to set these usage policies and data connectors to share data with one another. And we'd be really excited for your feedback to check it out, because we're in discussion with several members of the OpenTEAM community to see how we can build some use cases also here in the US to demonstrate its potential. So with that, I'll hand over to Vineet to give you an actual demo of how the whole system works. Vineet?
Thanks, Rikin. Just share my screen. Yeah, can you see my screen?
Yes.
Yeah.
Okay, thank you. Yeah, so I'll just give a quick overview of the use case that we're doing. So so essentially this is a very simple simple use case which demonstrates how the usage policies can exponentially enhance the offering. So FAO has a bunch of initiatives where they collect, they offer different services that can be integrated, and they're publicly available. And what they want to do is internally connect all these initiatives as well as sort of enhance them. So one such initiative is SADA, which is, if I go to this particular link on SADA, what it does is when I go there, it takes my lat long from my browser, sees that, okay, I'm from Bangalore, India, and there's this weather prediction model that they've built. Based on that weather prediction model, they are able to give me this particular prediction. There's a crop calendar model. I can select a zone and get the details about a particular crop and so on, and also on the indices. Now there are other people who are also offering these kind of services. What they want to do is basically integrate and also extend this. So one of the things that they found as a very good starting point was in the advisory section, where right now they have a bunch of just very basic textual thing, and they're working with the respective state governments where they can get these advisories, and based on the location and the crop, they can give the voice messages or also the text messages that are officially published. And one such use case that they wanted to pilot was with Digital Green, where the video library that we have can be embedded in this particular browser. Now the problem here is that if FAO has to get this video library for that particular location and that particular crop and so on, either they need to have access to our content that we have, which has a list of metadata about the videos, or they share this particular information about the location. Now, doing that content matching is not that trivial, and that doesn't scale up because they can do it Digital Green. We have everything openly available, but what if they want to further extend it? And there are certain restrictions that people would want to build on top of that as well. So the best possible way is that they share this particular location in the first case, but then sharing the location reveals the location of the farmer, and it is a personally identifiable information and sensitive in nature. And the various jurisdictions, they have a limitation that it cannot be shared outside, or it has to be shared. If it is shared, it has to be used for that specific purpose, which in this case has to be the advisory. So essentially, this is what the use case looks like. So on FAO side, so there are a bunch of browser side clients, and they are sending lat long, and we are initially just doing a very basic stuff where we have we give the recommended videos based on the location itself, and so this lat long is basically sent to the FAO system. Now they are operating a connector on their own system, and that connector basically forwards the lat long to the connector on the digital green side. And on the digital green side, there is a content matching app, which is, the connector itself provides a way for anyone to write application in the language, programming language that they prefer. And it lies in. And for that particular region, there's a mapping of what is the language, and it converts that lat long or the location into the specific language and calls the APIs of our own database where it passes on the language. So with the FarmStack connector architecture, what happens is that the information that is shared by FAO is first of all shared directly through this encrypted tunnel, and then it's used by this containerized application which they have authorized in the first place. So there's no way it's isolated. The data about the location is used inside this particular container, and the output of the video, recommended video, is then given back, which is then sent back on the client side. And what today we are going to show is how you can set this connector. So I'll set the connector on the consumer side first, where I have this particular application which I have hosted on, let's say, Docker Hub right now. So I can just easily interface, and then I can create a connector on the FAO side, and right now this is running on the same sort of system as a mock. It is to be, in the next few weeks, it will be live on the browser side, and we are emulating on the client side, sending out the lat long, where I can send a lat long and receive the videos. So I'll just take you through each connector setup one by one. So this particular, okay, there it is. So it's running on 1000. So here I have, I'll set up a connector which is the consumer connector. So selecting creating the consumer connector, creating this connector is basically, there's a template. I can select that I want to create a consumer connector. I can give the details. I can give some, this is a user-friendly name. I can give some app name. So let's say it is video matching app or something, and I need to give the URL. So here's how the URL looks like. I have this one here. So this is a containerized application that I've already hosted on Docker Hub. Docker is one of the widely used container the technology, and I can essentially create whatever code I write, I can create an app and containerize it in Docker. So I can give this link. That basically means that I'm configuring my connector which has this particular application which is going to access the data. I don't want to configure any usage policy or link it right now because I don't have anything. So I can finish this. So I have this connector up. I can go on and I can take out the next connector, which is on the provider side. So on the provider side now, I can select another, I can give a name, let's say FS provider. this is location sharing app, and I have, so this app is again there on the location side. This is the app on, yeah, I'll just go back on the diagram here. So this was the earlier one was a consumer side. On the provider side, I'm again configuring, and there's an app. So this is getting this location data and forwarding it to the code, and that is forwarding. Sorry. Okay. So yeah, so I need to just give the link of this particular Docker container, and here I can link the two connectors. So I can have a FS provider, so I can select a provider and I can select a consumer. I can link and run. Go to the next step. Now here, setting up the usage policy is simple. Basically, I'm saying that, you know, I want to ensure that the application that has been shared with me has this is the application. So this is the video list that is there. So this has the SHA-256 digest. So I can give either that digest itself, or I can basically take that entire link of that particular container, and I can say that only this application has the details, can access. So any connector that not any connector, but apart from the FS provider connector, the provider connector should have this application which can access. And what this essentially does is that if on the provider side I change, or on the consumer side I change a line of code, the digest would change, and that would basically break the data exchange. So that is what the usage policy does. It restricts the data usage for the specific purpose. In this case, it's for video content matching. So I can just finish this, and I have this connector set up. Now I can just go on the final output. So that's also right now on this particular port. So we are simply emulating this particular browser. So I can select some, and this has been, right now it is live in Ethiopia. So I can select some let's say, yeah, any point in Ethiopia. So I'll take this particular lat long and copy that stuff, and I can send this information to see the recommended list of videos. Yeah. So here it is. And I can send the location. So now what's happening is I have created this particular, configured both the connectors. I've configured on the provider side that I can share the data. I'm sharing it with FS consumer, this connector name, and it needs to have this particular app running, so that the data transfer can take place. And then once this app does the matching, it gives back the videos then that I'm getting back on my client side. That's on the browser side. It's yeah, it takes some time and at certain point of time, and I can get the list of videos out here, the recommended list of videos for that particular location. And essentially, it ensures the major plus point here is that not only on the consumer side, the FAO can now configure or share this with multiple organizations, the location. It can also help the organization. So right now we don't have any usage policy towards the reverse point, but there are different organizations. There's a sensitivity around the advisory itself. So if they want to impose further some policy that it should be shown for the users who are from that particular location, or something of that sort, those kind of policies can further be enforced by the by the content providers, and that is what it enhances the entire digital services portfolio offering for FAO. Yeah. So with that, I'll just sorry, maybe I think, okay, I'll just take out some previously tried out some stuff. Okay. Sorry, this is taking some time today. Yeah.
No problem.
We all understand nothing ever works when you need it to.
No.
It's totally fine. You're in good company.
Yeah. Yeah, it once happened that because this is right now in the staging, there was an issue in the net connection or something. Let me just check. Okay. Right. I'll have to again check it what has happened here in terms of maybe some sort of a connection may have broken at certain point of time in this entire pipeline. Yeah. Yeah, but this is how the use case works. So yeah, I think I'll have to debug this particular thing. Why this is stalled here.
Yeah, Vineet, maybe while we're waiting for that, we can also just open it up to some questions. I think we have plenty of content to mull over. So thank you both, Rikin and Vineet, for your presentation. And I'd open the floor for any questions.
I have a quick question. So this is Mike Stenta of FarmOS, which is basically a record-keeping application that's open source. So kind of what you were talking about before, that the idea might be that applications like FarmOS could perhaps hook into this to provide a way to share data with consumers. What would be the best place to get started exploring something like that from an app builder perspective?
Yeah. So you mean to say the code base of the FarmStack itself for the app builder? Is that the question?
Yeah, perhaps, or if there was maybe some documentation around, what would be a good way to get started as an app developer who is developing an application for managing farm data, but also wants to be able to share that with consumers using the FarmStack framework.
Yeah, so one of the easiest ways, so there's an entire code base on GitHub. You can the way the FarmStack architecture is and the technology stack, you can develop your own application and integrate your API. So with FarmOS, I guess one of the really nice way would be to create a connector with a which can have it depends on the architecture. It provides a lot of, flexibility in how you want to create that app. So whether you want to call integrate the APIs that are already existing, or you want to use it directly with the database that might be there. But you can just you can create a connector with that particular. So in this particular case, we are also from digital green side, like we are trying to create a connector with the videos that we have developed for the extension work, uh, and want to create that a generic app which can take in these kind of various parameters and return the list of recommended videos. So it adds as a sort of a recommendation or a matchmaking thing. The same way, the farm data management, if we want to integrate, one way to think about it is creating that connectors dedicated for farm OS kind of software. The other thing would be to think of it like a consumer as well. So if I want to get data from different applications that are already there, and get it and integrate in FarmOS, and then provide a service on top of it, that's another way. So you can create a provider or a consumer connector at both the places. The uh, it essentially is creating this particular application is really like uh, any kind of a Python or a Node.js kind of app that you want to integrate. Uh, there's a tool that we are also developing, which can which is right now in initial stages, but what it can do is create a GraphQL based API explorer, sort of, where it helps you create these apps quickly when you have these different applications.
Okay, great. Thank you. Yeah, and Greg posted a link in the chat to some documentation about creating a connector. So that makes sense. Thanks. I think it would be cool to have a FarmOS provider connector so that any other organizations that are consumers through FarmStack could potentially pull data from FarmOS instances.
Yes.
Thank you.
Yeah, you can think of, I would think of it like like today you have connectors for various applications out there, uh, uh, similar to something like Fivetran kind of a systems, where I have these connectors for applications like let's say a Jira or a Slack. And the same way I can create these connectors for various applications that are already there.
Yeah, and we would be happy to work with you, Mike, on that. I think, yeah, that'd be super cool to kind of create a templatized connector for FarmOS that others can use for their own applications that plug in or pull from FarmOS.
Yeah, that would be great. Yeah, I think that would be a cool use case to explore.
Can I, this is Greg from our side. So we push a lot of data, we push and pull a lot of data to FarmOS as an example case, but it's through just a web API. So, I mean, I think there's this sort of like the connector concept, and I'd like to better understand the value of that in our case. And then there's like the application of a data usage agreement. And that one is very clear. That one that makes a lot of sense. Basically, for anything that we would be sending around that relates to farmer information, it would be nice to include that. So I have two questions. Like, what is the value of, if you already have an existing API connection, what is the value of that connector above and beyond the existing tools that we would use, normal API tools, I guess? And then how does that that usage agreement, like, how does it show up? You know, like if I'm receiving the information, like where is the usage agreement? Is it attached in some way? Is it like part of the message that's being sent? How is it referenced? Is it enforceable in any way? Like I'm assuming it can't be enforced like in code. It's just a reference piece of information, but just more about that.
Yeah, sure. So yeah, so on the second question on the usage agreement, the way it happens is, so each of the connector is assigned a certificate, and there's we use a protocol. So FarmStack is built on top of the IDSA, so we use that protocol, and essentially the usage policy is created and enforced in that protocol itself, and the entire architecture is a sort of a message driven architecture. So so as soon as I create a connector, there's a message that is sent to the network, or when I'm trying to link the connector, there's a message that is sent, and based on those messages, the further routing of the data happens. And it is when the data, every time the data transaction takes place, that usage policy. So there's a file that is created inside that, that protocol itself. So there's a huge bunch of documentation around that particular stuff. I can share the links on how this message and event driven messages work, and how that uh, the usage policy actually happens. In fact, the architecture goes beyond. Right now what we are doing is simply like, I'm creating this usage policy, and I'm saying that this is my usage policy, uh, 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 and then that usage policy is then enforced. uh, it's a there's a autonomous sort of a contract negotiation. So each usage policy consists of a contract. It's not a contract in a legal sense. It's a contract as more of an artifact, a software artifact there. And that contract has different properties. One of the properties is that the detail about the application itself, and that negotiation can also take place. So there's a possibility to even enhance it to create a very dynamic kind of a usage policy as well. So I can share all those links if you're interested, how that happens. In terms of the APIs versus connectors, yeah, I think it depends on really on the use cases itself. So APIs are the flavor for it also depends on what is the integration pattern that suits best. APIs are like, the bare wires that I'm just tapping in, while what connector does is it creates an application. It encapsulates a, I can encapsulate the entire APIs inside the application, and that can be inside the connector. So it's like a socket that I've created, and now I have these connectors that I can connect it with different systems. So essentially, if it's a, let's say, one-off, or integration, APIs still tend to be the way to go about it. Where APIs get APIs provide, API based integration provide a lot of flexibility, where they tend to get messier over a period of time, is when you have a lot of different you want to share data with a lot of different actors, and share and manage all those credentials. So you have to either rely on some sort of an API management tool, which in this case is also possible. You can do it outside, behind, from your database. But the big plus is the socket, and then the peer-to-peer connection, because what we are doing is not just creating a connector that encapsulates the application, but then each connector is assigned an identity, and each connector can interoperably talk to another connector, and then that helps it enforce these usage policies on top of it. So so it's like I can integrate my APIs once and forget it with my set of usage policies, and that sort of improves your integration effort a lot, and it creates a kind of a also a no code kind of a way if uh, those uh, those connectors are there. So for example, like we have uh, we have connectors or the for ingesting APIs, let's say from different databases. So I can use those applications based which will retrieve from those databases or the data warehouse, and uh, and I can just create that connector once, and it's just easier to interface that entire thing and operate it.
Thanks.
Thanks, Vineet. Thanks for the questions, Greg and Mike, and for the documentation links you sent, Rikin. What other questions do we have? Maybe a question for Rikin is just how you see FarmStack integrating into OpenTEAM's current work, and in the future, how you'd see it working with OpenTEAM. And I think the next question after that is that I would have is how we can support FarmStack in the work you're doing.
Sure. Yeah, no, thanks. I think one is I would check out the FarmStack website and the documentation that we've shared on the links. I think there's a bunch of threads, in the OpenTEAM community that we're working on together. One is, of course, like the data sharing sprint that took place, and now how that's kind of moving into the clearinghouse collaborathon, and eventually into some of the data wallet type of conversations. And I think the points that Mike and Greg pointed out around maybe a potential first use case within OpenTEAM could even be the SurveyStack FarmOS sort of connector that we could help to templatize, and that others could then build on top of or leverage for their own use cases. And then there's interest in the Collaborathon series around thinking if we could create a proof of concept use case that brings together, let's say, like Regen Network and some of the field hub groups, like the California Field Demonstration Network, together with Tim's Terragenesis work. If we could just show how two or more actors could leverage FarmStack from the point of view of protecting the data providers' interests when they're sharing their data with some data consumer, which could be, there's also those USDA conversations around the whole dynamic soils hub discussion. That could be an example, because just to add on to what Vineet shared in response to Greg's point, the big difference also with connectors, the FarmStack connector vis-a-vis other connectors and even other APIs, is that what's being created is a container, a trusted execution container on the consumer, which allows the application of the data consumer to be run within that container with these restrictions that the data provider has been set around them. Unlike an API where obviously you just are pulling or pushing data from it. So the point of doing this would largely be where there is some kind of data protection or security requirement, whether it's privacy or some other thing that the data provider wants to enforce. And so it's kind of giving you a lot more than just the pulling and pushing of data. It's actually creating this execution environment where the consumer's app is run. to, I see, oh, nice. I see Shafali's question. So like one of the major like limiting factors for this right now is a bit of a combo, it's a chicken and egg problem around people do share data like between third parties. So, but I think a lot of people have not yet thought too much about the data protection requirements when they're sharing data. For instance, in India, they do have this consent requirement that the data protection bill has. But today it's just like a clear text field that people get, like say that I got consent or I didn't. But then like what happens after that? That like, how is that consent actually factored? What happens if like the person who got the consent passes that data to yet another third party? How does it cascade? Those elements around like enforceability are only beginning, I think, to happen as people start to work through like those obvious sort of like challenges. And then the second big thing is a larger sort of discussion needs to be had with respect to the overall governance of like this whole protocol and the way that these usage policies are set at a jurisdictional level. And so like in India and Ethiopia, we're working with like these ministries of agriculture to take on that responsibility of being a so-called FarmStack steward of the network. We don't want Digital Green to be like that steward. We think it should be the public and maybe eventually more of a consortium-based approach. But I think that if we can show some proof of concept use cases with a couple of popular applications like FarmOS or and other systems like DSP Hub or Region Network or Teragenesis, that kind of stuff, then I think there's an opportunity to take that proof of concept to some kind of anchor organization who might be well suited to be a steward, which maybe in the US could be a USDA type of entity to begin with before like maybe a consortium takes on more of that responsibility. But yeah, that's what at least we've been finding in the other geographies like in India and Ethiopia that we operate.
Other questions? Thank you, Rikin. I think there's a lot of opportunity here and a lot of information to consume as well. Any
maybe
final...
Maybe the last thing I would just mention, Laura, is like, because we've been having some of these separate conversations with people like Mike and Greg, FarmOS SurveyStack, as well as with Tim on Teragenesis, is just to say that like, because most of our work is abroad, there's a lot that we're also trying to like learn and adapt from your all solutions, as we've in a lot of the discussions together, to whether it is like internationalizing stuff like SurveyStack from both a linguistic point of view, but also in terms of like a UX point of view, with like more of a visual language and stuff. Like we think that some of that stuff is really great that you all have kind of built foundations of, and then we're trying to like plug in FarmStack onto those same systems, right, that we're adapting into like our work abroad, whether it's like the farmer registry that we're trying to build out in Ethiopia with the Ministry of Agriculture, or this notion of kind of a farmer wallet for farmers to track their agronomic practice info for monitoring, reporting, and verification types of purposes for a very similar type of use case, like of the sort that you all are working here in the US for a quantification of greenhouse gas emissions and building some of these like carbon marketplaces. So I feel like although like our work is more kind of in the global south, I think there's a lot of similarity like on the back end with whether it is like the question set that you guys have really thought about, or the data structures around farmer and farmer profile info, or this element around data use and protection, that at a base level of the tech stack seems very similar. And so we're very eager to kind of continue this collaboration, even if at the front end, the actual applications and the actual commodities and all that will obviously vary across contexts.
Yeah, I agree. And you know, from our perspective with FarmOS, we're already tackling a little bit of access control, but only on like the technical level of the, you know, OAuth scopes kind of for our API. So that, you know, that has a very hard defined permissioning structure to it. But what we're not tackling at all is the larger, like, you know, policy level things that you're talking about. And so I see it as a great complement, a great fit.
Great. Well, thanks again, Rikin and Vineet. I think we'll close out here today. Yeah, a lot of information to consume, and really eager as well to plug you in into real use cases that exist within our community. So thanks again, everyone. And we'll see you soon in a couple weeks. I think Dr. Chris Covey will be presenting on what he's doing with soil organic carbon measurements in the field and tools that may be available. So we look forward to that presentation in a couple weeks. Have a good day, everyone.
Thank you.
Thanks.
Thank you.
Thanks.
Thank you, everyone.
Thank you.
Thanks.
Yeah, thanks so much.
Thank you.